The 3D Systems automated parts washer was designed by Fall 2021, Senior Design Group 19, and sponsored by North Dakota State University. Team members include David Babb, Morgan Kapaun, Adam Krueger, and Jaden Streed. Project mentor was Dr. Yechun Wang. Department contact was Rob Saylor. Class organization thanks to Dr. Ali Amiri. Cured resin 3D printing is a breakthrough technology that's recently been popularized in industry. This technology allows for parts to be made in an incredibly high resolution with superior surface finishes to conventional 3D printing. Obstacles do arise in this type of printing, however, with every part produced being fully encapsulated in support wax. Removing this wax is no trivial task, with cleaning being a tedious and messy process. Tasked with designing an appliance to simplify cleaning, we set out to create an automated parts washer. Early on, a water and detergent mixture was determined as the best method for cleaning the part. Following this decision, design began on a parts washer with the ability to heat water and pump it around the part. For added agitation in cleaning, the design focused around using an ultrasonic cleaner, which assists in breaking up the wax. Criteria for design were easy to set with a straightforward top goal. The final product must be a fully functional, automated, self-contained cleaning station that requires little input from the operator. The cleaning cycle should yield a clean part with little to no deformation. Secondary targets were defined as well. Water heating time must be kept to a minimum, around 15 minutes. Fluid volume should not exceed 3 gallons, and any waste slurry needs to be biodegradable and drainable. Using the targets as an outline for design, the 3D Systems parts washer was designed consisting of an off-the-shelf ultrasonic cleaner and an array of attachments and modifications. Cost declared the pre-built unit as a good foundation to design the project off. The unit consists of the off-the-shelf sonicator with an attached side tank. This tank has a pump attached at the bottom for pushing water through the primary plumbing loop. The water is heated inside the loop by a self-contained insertion heating element and re-enters the system through a fabricated outlet manifold. A filter assembly is contained within the side tank for collecting wax during fluid circulation. We quickly entered the manufacturing phase to continue the project. Sheet metal work was sent to Cheyenne Forming for cutting and bending, while assembly of the tank to the sonicator was done by Rob Saylor here at NDSU. The control system was installed in a 3D printed enclosure built beneath the unit, allowing for self-containment of the assembly. The electrical system was designed for full control of the final assembly, with automatic temperature control and electronic switches for each main function of the device. The water in the secondary tank passes through a series of perforated stainless steel sheeting, aiming to keep contaminants out of the pump. The final product yielded is a parts washer that holds approximately 3 gallons of fluid. Taking 20 minutes to heat, the system now reaches its operating stage hours faster than the aforementioned cleaning apparatus. Parts yield a clean surface finish after the bath, making the MJP2500 Plus printer a far more viable option for use in industry.